All right, living environment fans from across the globe. It's another Bellringer, another day. It's a Monday, start of a brand new week here in January. And we're only like now a week away from a midterm exam. That's pretty exciting. I gave you a study guide last week and hopefully you started studying it. I'm not in the office today. You probably noticed that already. I've got to go to the dentist, get something, my teeth cleaned and checked out for the day. And then, yeah, luckily I've left some sub-plans with lots of things for you to do today. And at the end of this Bellringer, I'll go over them with you. Got it?
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class.
Scopes, baby. That's what we've been talking about. Microscopes. We started using them in class last week. We're going to continue to use them this week for a couple of different lab activities, including finishing up the cells lab that we started, or some of you started last week, and others will start tomorrow. Anyway, let's see what you can remember, what parts. How about this part, the part you look through? What's that called? Good, that's called the eyepiece lens, the eyepiece lens. All right, and then how about the other lens that you use, right? What are those called? There's three of them. Right, we call those objective lenses, All right, and then of course there's two knobs on the side, both of which do the same thing. They move the stage. The one on top is called the coarse focus, and the one on the bottom, which does the same thing almost imperceptibly, is called the fine focus. All right, and so we set up their microscopes last week, and we looked at least a glass slide where we drew on it and we found all of our markings and stuff like that. Now, when you look in the microscope, you always see a circle of light, right? The circle of light is called the field of view, And what's weird about a microscope is when you switch magnifications, you actually change the field of view, although the circle will appear to be the same size. It's kind of weird, and that's something you need to know for sure. Right? The field of view is that circular area that's visible when you look through the microscope. Right? So what happens when you look through the microscope at the different magnifications, the circles all look the same size, but in reality, they're different sizes. The 40x circle is bigger, the 100x is smaller, and then the smallest, tiniest one is the 400x, right? So it's important to know that when you look at your high magnification, you see less stuff. When you look at the lowest magnification, you see more stuff. Right, so in that regard, in the smallest field of view, you'd see the most things, right? 10 happy faces. But once you bump up to the medium size, you see less. And then of course, if you go to the super extreme, you see even less, right? And we can use this to estimate the size. Like if let's say your field of view was 1 centimeter across, you can count 10 smiley faces, you know that each smiley face was worth 1 millimeter, right? If you switch the focus in half, you're gonna get less. The size of the smiley faces stays the same, they just look bigger, okay? Hopefully that makes sense to you. Of course, microscopes works because we have eyes, and just a quick reminder of how eyes are built, right? Your eye is this big circular ball that's hollow, but it's filled with this liquidy tissue called the vitreous humor, right? And in the front of the eye is your pupil, which is the opening that lets light into your eye. Right behind the pupil is a lens. Lens is made out of protein. And the lens, what's interesting about lenses is that they are very pliable until you get older. They start to harden up, and then that's why so many people, myself included, need like reading glasses once we got older, because our lenses became less pliable. They're harder to stretch and to move around, all right? So when you use a microscope, right, you want to, let's see if I can get this right. You want the light to come through the microscope and hit you in the eyeball, right? So what's interesting about it is, right? The light goes from the object, through the objective lens, then through the eyepiece lens, then hits you in the eye, and you adjust the stage in order to change where the light hits you in the eye so that you can actually see it. And then what happens, of course, is those cells send nervous signals down your optic nerve to the back, your occipital lobe of your brain, and that looks like something, right? What happens during this time, of course, is the object gets flipped, inverted, so things look upside down, and then your eyeball recalibrates or right sides up that image. So, yeah. Anyway, let's so get on. Today in class, since I'm not here, let's see, Bellringer. I'm gonna have you watch Ed Puzzle about cell parts. We're gonna start studying the different parts of cells. Okay, and then there's a notes page for you to do. It has to do with cells and how they're built like cities. And you need to understand this, how is a cell like a city? If you're in lab, I'm gonna take it easy on you today, and I'm gonna give you the first part of a little film, which is kind of a silly film, but it's a fun film to watch, about microscopic beings in the human body and immune system and that kind of thing. So I hope you enjoy that. And then tomorrow we'll get back at microscopes.